small box of mass 40 kg is moved along a rough horizontal floor by 3 men. Two of the men apply horizontal forces of magnitude 100 and 120, making angles of 30 and 60 respectively with the positive x-axis. The third man applies a horizontal force of magnitude F Newton, making an angle of alpha with the negative x direction. The resultant of the three forces acting on the box is in the positive x direction and has a magnitude of 136 Newton. So they've told us the direction as well as the magnitude of the resultant force. This means that the vertical forces, this is the vertical component, this would be a vertical component, and this would be a vertical component. They should sum up to 0. There is no vertical component of the force R, the resultant force. So let's find the vertical component and then equate them to 0. This one is going to be F sine alpha upwards. This is going to be 100 sine 30 upwards. This is going to be 120 cos 6, sorry, sine, not cos, sine 60 downwards. Okay, now Ry would be, add the upward forces, F sine alpha plus 100 sine 30 minus the downforce 120 sine 60, and this is equals to 0. So we can make F sine A the subject. It's going to be, what is 100 sine 30? That is 50. So 50 goes to the other side, minus 50. And then 120 sine 60 is minus, this would be minus 60 under root 3. When it goes to the other side, it becomes plus 60 under root 3. Okay. Next is the value of Rx. Rx would be the sum of the horizontal forces in the right direction minus the sum of forces in the left direction. So towards the right, we have in this direction 100 cos 30. This one would be 120 cos 60. And towards the left, which will get subtracted, we have F cos alpha. Okay, so 120 cos 60 plus 100 cos 30 minus F cos alpha equals to 136, because this is actually the horizontal component, because the vertical component Ry is already 0. So this is actually just Rx, which is also the same as R, since there's no horizontal component. Okay, now let's make F cos alpha the subject here. So F cos alpha goes to the right, becomes positive. What is 120 cos 60? It is 60 plus 100 cos 30, that is 50 under root 3 minus 136. Okay, and 60 minus 136 is minus 76. So I can just write minus 76 here or here. Okay, now we need the value of F and alpha. So I'm going to first divide these two equations, because when I'll do F sine alpha upon F cos alpha, I'll get tan alpha. And then tan inverse will give me the value of alpha. Okay, F and F gets cancelled. This becomes tan alpha. And then we take tan inverse. So alpha would come out to be 78.876 rounded to 78.9 degrees. And now we need to find F, so we can substitute it in either equation 1 or equation 2, the value of alpha. So F would be, if I'm using equation number 1, F equals minus 50 plus 60 under root 3 upon sine 78.9. 54.9554, which gives 55.0. So we have the value of F and alpha. What else is this question asking for? Given that this box is moving with a constant speed, state the magnitude of the frictional force acting on the box and hence find the coefficient of friction between the box and the floor. Okay, so we need to find the magnitude of the frictional force. Okay, we're going to use Newton's second law, which says forward force minus backward force is equals to ma. Since the speed is constant, acceleration is zero. So we can say forward force is equals to backward force. Forward force here is going to be the resultant force, the resultant of the three pulls that this mass is getting. So R minus the backward force is going to be friction, or sorry, is equals to friction. So friction is just equals to 136 Newton. Next, they've asked for the value of the coefficient of friction. So we know friction is equals to mu R. So 136 is equals to mu. Normal contact force, since this was a horizontal surface and there's a mass of 40 kg, that means there's a weight of 400 newtons, meaning there's a normal contact force of 400 newton as well. So divided 136 divided by 400 will give us the value of mu, which comes out to be 0.34.